Good morning to all. So now we are going to discuss some of the problems on chimney draught system. Okay. So let us consider some of the problems on chimney draught system. So what is the problem? The given problem is, so calculate the mass of flue gases flowing through the chimney when the draught produced is equal to the 1.9 centimeters of water and temperature of flue gases is 2290 degrees centigrade and ambient temperature is 20 degrees centigrade. The flue gases formed per kg of fuel burnt are 23 kgs. Neglect the losses occurred. Take the diameter of chimney as 1.8 meters. So this is the given data. Okay. So we have to determine the discharge height of the flue gases. That is H1. Okay. So for determine the value of H1, first of all we have to determine the value of height of the chimney. Okay. Now solution, we are try to solve the solution. So the solution is obtained as the draught. What is the data given? We are writing, first of all we are writing the data given. So the draught in mm is given as 19 mm of water. Temperature of flue gases is given as Tg is equal to 290 degrees centigrade. Ambient temperature is given as Ta is equal to 20 degrees centigrade. Flue gases formed per kg of fuel, that is Ma plus 1 is equal to 23 kgs. Okay, this is the data given. Okay, now the diameter of the chimney given as D is equal to 1.8 meters. Okay, next the mass of gases, that the mass discharge of gases can be determined. Discharge of gases from the chimney can be determined using formula A into C AC into rho C. So whereas A is nothing but cross sectional area and C is the velocity and rho G is the density of hot flue gases. Okay. So to determine the cross sectional area of the chimney, the formula is A is equal to pi by 4 d square. Okay, since the diameter of the chimney is known, we can substitute in the value of diameter D is equal to 1.8 meters. We can define the cross sectional area of the chimney A. Okay, so the cross section velocity. Now in the discharge equation, the formula is area into velocity into density of hot flue gases. So we are going to determine the area using formula pi by 4 d square, and velocity is square root of 2g h1. We have discussed that. So velocity is c is equal to okay, c is equal to square root of 2g h1. So to determine the value of c, the velocity of air flow or flue gases is c is equal to square root of 2g h1. So we know that we know the formula to determine the value of h1. So h1 can be determined as 353 h into ma by ma plus 1 and tg by ta minus 1. Tg by ta minus 1. So in this to determine the value of h1, so we know that we have to know the value of h, ma and tg, ta values. Okay, so here the ma plus 1 value is given as 23 kgs, therefore we can have the value of ma as 22 kgs. Okay, so tj value is given and ta value is given, so substituting those values we can determine the value of h1. Okay, now see here, h1 is nothing but the discharge of gases at particular height. Okay, so here h represents the diameter of the chimney and h1 represents the equivalent height of the hot flue gases discharged to the atmosphere. Always we are stating that the flue gases will be discharged to a certain height more than the chimney height. Therefore this is h1 is the equivalent height of the flue gases discharged. Okay, so h is the height of the chimney, Okay, so now to determine the value of h1, so we have to first of all determine the value of h. So h can be determined by using data hw. So hw is given, we know the value of hw. So hw is equal to 353 h into 1 by ta minus ma plus 1 by tg into ma. So now we know the value of ma plus 1, we know the value of ma, we know the value of tg, and we know the value of ta. And we know the value of hw also we know. So substituting that, finally we used to get h is equal to 34.67 meters. Okay, so now substituting uh, substituting in the value of h, and uh, so by 37 meters. Okay, so now density of flue gases is obtained. So density of flue gases, so rho g value, we have solved the rho g value as 353 into ma plus 1 by ma into 1 by tg, 1 ma plus 1 by ma into 1 by tg. Okay, now so that is the density of, by substituting the values, we have obtained the density of hot flue gases as 0.655 kg per meter cube. Okay, next, substituting the values of density and height of the flue gases in the density and height of the flue gases column in the column h1. So we can have the value of h1, substituting value of h in the h1 column h1, we can have the value of h1 as 9.5 meters of air, and velocity of the flue gases is obtained as c is 23.98 meter per second. Now finally, substituting the value of rho z, a and c, we can have the mass of flue gases passing through the chimney as 39.8 kg per second, 39.8 kg per second. Okay, so this is the one of the problem that we are going to solve. Next, we are going to solve another problem. So here, calculate the height of the chimney. Another problem is calculate the height of the chimney required to produce a draught or equivalent to the 1.7 centimeters of water if the flue gas temperature is 270 degrees centigrade and ambient temperature is 22 degrees centigrade, and minimum amount of air per kg of fuel, minimum amount of air per kg of fuel, okay, is 17 kgs, 17 kgs. So now we have to calculate the value of h value, we have to determine the value of h. Okay, so now what is the data given? First of all, we have to write down what is the data given. So draught in mm of H2O is given as 1.7 centimeters. So if you convert it to the mm, we can write it as 17 mm, 17 mm. Okay, so next, temperature of flue gases Tg, temperature of flue gases Tg is equal to 270 degrees centigrade. It has given it as 270 degrees centigrade. If you convert it into the Kelvin, so 270 plus 273, that is 543 Kelvin. Okay, next, ambient temperature Ta is equal to 22 plus 273, that is 295 Kelvin, 295 Kelvin. Okay, so minimum quantity of air per kg of fuel. Okay, so he has given MA value as 17 kgs, is MA value is given as 17 kgs. Okay, so now using the relations HW is equal to 353 H into 1 by TA minus MA plus 1 by MA into TG, we can determine the value of height of the chimney, so that is H. Okay, so substituting the values, HW is 17, 353 H into TA value is 295 Kelvin and TG value is 543 Kelvin. So MA plus 1, MA is value is given as 17 kgs, MA plus 1 is obtained as 18 kgs. Substituting that, we should finally get the equation as 353 H into 1 by 295 minus 18 by 17 into 543. Okay, now that we can obtain as 353 H into 1 by 295 value is obtained as 0.00339 minus 18 by 17 into 543 is obtained as 0.00195. Okay, so finally we should get it as 0.548 H. From this, we can write determine the value of height of the chimney. H is equal to 33.46 meters, 33.46 meters. Okay, now that is the method to determine the height of the chimney, from the given problem, Okay, now we are going to solve another problem, that is a chimney height of 32 meters is used for producing a draught of 16 mm of water. The ambient temperature and flue gases temperatures are 27 degrees centigrade and 300 degrees centigrade respectively. The coal burn in the combustion chamber contains 81% of carbon, 5% of moisture and remaining ash. Okay, so what are the fuel burned in the combustion chamber? That flue gases contains 81% of carbon, 5% of moisture and remaining is gas, remaining is ash. Okay, now now what is the required quantity of air, that to required amount of air for complete combustion of the fuel. For complete combustion of the fuel, we have to determine. Okay, neglect the losses and assume that the value of burnt products is equivalent to the volume of air supplied. So here it has given that total quantity of air supplied is equal to the amount of air supplied is equal to the amount of volume of burnt gases, and complete combustion of fuel. Find the percentage of excess of air supply. Okay, now to calculate that, so what's of all we have to write down what is the data given. So in this data, the height of the chimney is given as 32 meters and draught is given as 16 mm. Ambient temperature is given as 27 degrees centigrade, that is 27 plus 273, that is 300 Kelvin. Flue gas temperature is given as 300 plus 300 degrees centigrade, conversion of into Kelvin, 300 plus 273, that is 573 Kelvin. Okay, now what is the percentage of carbon in the fuel? So unburned fuel, what is the percentage of carbon? Is 81%. And first we have to determine what is the percentage of excess of air supply. Okay, so we know that HW is equal to 353 H into 1 by TA minus MA plus 1 by TG into MA. Okay, so now substituting that, we can have HW is given as 16, 353, and H is given as 32, height of the chimney, divided by 1 by 300, TA value is 300 Kelvin, minus of 1 by 573, TG value is 573 Kelvin. So we doesn't know the value of MA and MA plus 1. Okay, so we have kept MA by MA plus 1 by MA as same. Okay, so now we are taking the denominator, we are taking 353 into 32 opposite to the equal to, therefore the numerator will become denominator. Therefore we can have the value as 16 divided by 353 into 32 is obtained as 1.4168 in 10 power minus 3, that equal to 1 by 300 value is 33.33 in 10 power minus 3, minus 1 by 573 value is 0.1745 into 10 power minus 3, MA plus 1 by MA. Okay, so now so in the here we are taking 10 power minus 3 as common, therefore we can have it as 1.416 is equal to 3.33 MA minus 1.745 MA minus 1.745 divided by MA. Finally we can have this, we can write it as 1.416 MA is equal to 1.586 MA minus 1.745. So that by solving it, by taking equal to opposite to the equal to, we can have it as minus 0.17 MA is equal to minus 1.745. So finally we have the mass of air supplied is 10.16 kg per kg of fuel. Okay, so this is obtained. So by solving theoretically, we have obtained the equivalent mass of air supplied for burning of 1 kg of fuel is obtained as 10.16 kg per kg of fuel. Okay, now so let us assume we know that carbon plus oxygen is the burning of the carbon in the presence of oxygen, we can produce the carbon dioxide, that is C plus O2 is equal to CO2. Okay, so now we know the C value, carbon value as 12 and oxygen value as 32, that is finally the product combination of product value is 44. Okay, so that means for 12 kgs of carbon we require 32 kgs of oxygen, and finally the combustion product is produced is 44 kgs. Suppose for 1 kg of carbon, what is the quantity of amount of oxygen required? Is 1 kg of oxygen, 1 kg of carbon we require 32 by 12. So that is if we divide all these terms with numerator and denominator with 12, so we used to get it as 12 by 1 kg of carbon, we require 32 by 12 kgs of percentage of oxygen. Therefore we require 8 by 3 kgs of oxygen for burning of 1 kg of carbon. Okay, so for finally if you consider all the remaining elements in the remaining elements So we can have the required quantity of air supplied to be supplied is 8 by 3 into 100 by 23. So that is finally we stopped it as 11.6 kg of air. 11.6 kg of air. Okay. So in the problem has given that there are only for 1 kg of fuel contains 0.81 percentage of carbon. The 1.8 percentage of carbon. Therefore, if we multiply the total percentage of air with 0.81, we can have the quantity of air supplied for kg of fuel. So that is 11.76 into 0.81, that is 9.396 kg per kg of fuel, kg per kg of fuel. Okay. So now uh, what have to determine? We have to determine the percentage of excess of air supplied. So what is the mass of air we calculated from the theoretical value is 10.16. What is obtained from chemical reaction value is 9.396. Therefore the percentage of air excess supplied is 10.16 minus 9.396 divided by 9.396. We used to get it as finally it is as 8.13%. 8.13%. This is the percentage of excess of air supplied. Okay. So this is the methods to solve the problems on chimney draught systems. So we can easily determine the values that can be obtained from the given data. So just we have to take consideration what is the data given. Okay. So always the ambient temperature represents the value of Ta, and flue gases temperature, whether in the problem it has given as flue gases or hot gases, it is assumed to be Tg. It is assumed to be Tg. So in the problem, if it is given in terms of of water, that value is Hw. So here just remember that if the problem has given the height of the chimney, it's the value, the form, that is H value. Okay. Otherwise, equivalent height of the hot flue gases discharged, if the problem is given that equivalent height of the hot flue gases discharged, so that is the value is H1, H1. Okay. So now and that is to be considered, and the formula for discharge of flue gases through the atmosphere, mg is equal to discharge rate, mg is equal to rho into a into c. So a is nothing but cross sectional area, the formula is pi by 4 d square, and c is nothing but velocity through flow rate velocity, that is c is equal to square root of 2g h1. Whenever we are going to determine the velocity, we have to substitute the value of h1, not the value of h. So that is square root of 2g h1. And we can determine the rho a values and rho g value. Rho a value is 353 into 1 by Ta, and rho g value is 353 into 1 by Tg into Ma plus 1 by Ma plus 1 by Ma. That is the formulas. And diameter of the chimney. What is the diameter of the chimney? The diameter of the chimney is 1.128 into square root of rho by m by rho g. Okay. So by using these formulas, we can determine the diameters, velocities, and height of the chimneys, and whatever the problem data given, and according to the problem required determination in the problem, we can solve using these formulas. Okay. So in the next class we are going to discuss some more problems on the chimney and some other boiler mountings and accessories and some other types of boilers. Okay. Thank you. Thank you.